Good morning, everyone, and welcome to the webinar. Today, we are going to talk about one of the most exciting and fastest growing workloads in Microsoft Fabric, real-time intelligence. Real-time analytics helps organizations to analyze their data the moment it is created, bringing instant insights to operational systems, customer experiences, and business decisions. It is built on a powerful Custo engine optimized for high speed ingestion and low latency querying of large volumes of streaming data. So, whether it is telemetry from IoT devices or website click streams, or even application logs, real-time analytics helps you detect anomalies, detect patterns, and act quickly. It also integrates seamlessly with Power BI, allowing you to visualize insights as soon as they happen. I'm Toral Goradia, Chief Operating Officer at Santor Technologies, a Microsoft Fabric featured partner specializing in data analytics and AI. We help organizations modernize their data platform and unlock real business value leveraging AI driven insights. Our team has successfully delivered several data and AI solutions across industries. We specialize in helping customers or organizations migrate from other visualization tools such as Click, Tableau, on prem and in cloud databases to Microsoft Fabric and Power BI using our proprietary Migrate to Fabric solution. Today, I'm joined by Ginger Grant, who is a Microsoft Data Platform MVP. She is a Microsoft certified trainer and a recognized expert in data and AI. Welcome, Ginger. Welcome
Thank
to the
you.
webinar, and we are so glad to have you here today sharing your insights on real time analytics. Ginger, during Microsoft's Q3 earnings call, Satya highlighted that real-time intelligence is becoming the fastest growing workload in Fabric. As a matter of fact, in just 5 months since it went into GA, 40% of Fabric customers are already leveraging it. So, which really speaks to the demand for real-time insights across industries. So, this is amazing. Would
Yeah.
love to hear your thoughts on that, and then dive into the presentation.
Well, I've been looking at streaming analytics for various industries for a number of years. And to be honest, these solutions for managing streaming data has always been really complicated. Getting the data streamed, getting it out, processing it, the steps involved were rather cumbersome. And they didn't offer a lot of really good ways to do anything other than see it once it's streamed. And some of the features that we're going to be talking about today basically are incorporating not only, okay, here's the data, but what do I want to do with it right now? Because it's real, do you have that immediacy of data that is being sent to you? You also need to process solutions in real time as well. And we'll see how Fabric can help us do that. All right, so let's get started talking about the different elements of streaming. So streaming data, that's often part of a data environment. I mean, people have data that's coming to them from different places, or perhaps you just want to monitor your social media feeds and see what's going on in real time. Companies don't want to miss on some kind of trend that may be adverse to their business by some rando thing that gets put up on Reddit or X, formerly known as Twitter. So you want these are things that people want to look at. Also, things like positioning data for GPS for the large number of vehicles. It's not uncommon at all anymore to see a vehicle that is driving around that on the back of it has a sticker that says this vehicle monitored by GPS, and that's monitoring in real time. They can monitor how fast that vehicle is going and tell them to slow down, or tell them that they ought not to be driving a cement truck through a drive through, because that's a good way to damage either the signs or the truck itself. So we want things that can handle processing this in real time. What can we do to provide meaning? Of course, you want to store the data for later, obviously, but we need tools that are designed to handle this and how to process it in a way that provides a lot of value and can do real time analysis and do actions based on what's going on. And you can even add it to a database or to OneLake so that you can look at it later. A lot of times, the data that is streamed is valuable in two different paths. One of the paths would be, I want to act on it right now, and another one is something that maybe your machine learning and or data analysts or legal might want for later on. They want to take a look at that raw data um, and create some meaning out of it. So it's got two lives. One of them, like immediately right now, give me an answer, and also let's analyze over time the data that we're getting, because it's generally in lots of detail, summarize it, and provide value for people. So we want to be able to provide it in both ways, and that's something that Fabric can definitely do. So taking a look at this diagram that shows you how um, that you process with real-time analytics, really the data sources can be just about anything. They can be coming from various IoT devices, anything from mattresses, which believe it or not have IoT devices in them, Fitbits, GPS, social media streams, any of these different things can be ingested. And you have many options for how you can bring them in. You can bring them in using Kafka. You can bring them in using Event Hub. A number of different methods are supported. And for testing purposes, you can even stream data that you already have stored in a lakehouse or a warehouse so that you can test it, which is great because you want to make sure that it works before it's turned on, and you also don't want it to divert live production data just so that you can run some kind of a test. So all of that is supported. What's really great about this is that Microsoft is embracing not only the open source community with their solution, but also supporting people who have been with them for years in some proprietary methodologies like Event Hub. No matter how your data comes in, when you connect it to an event stream, you are going to be receiving that data in real time, and you have the ability to do things with it. You can analyze it, you can transform it, and you can store it. Now, of course, anything that you store inside of Fabric is stored inside of OneLake. So this is a cloud-based solution that you can use for your data. Now, I once worked for a concrete company that got GPS data every 10 seconds. And as you can imagine, if you've got a fleet of 70 trucks rolling around, that's a lot of data. But it was needed for analysis in later on, because we analyzed vehicles information to determine different ways that people are driving and how that impacts maintenance costs on a given vehicle, as well as things like legal. So having it inside of OneLake means that you have the ability to store a lot of data relatively inexpensively. You could also choose to migrate it to cold storage so that you have the data available for you in the cloud so that you can access it whenever you need to. But how are you going to be accessing it? Well, a number of different ways. I also worked at a company where we were streaming call center data. And one of the things that you want to do with call center data is put the information visually up on a screen so that people can see information that they were getting from the phone switch, like how many people are currently on hold, what do they say that their issues are. You can visualize that, all of that, immediately inside of Power BI. And another really cool feature is the ability to act with Activator. So if you want something to happen, you can make that happen. For example, one of the things that we implemented in a solution that I did previously for call center information, if all of a sudden all of the topics were, say, billing, then in real time, what would happen is that they would send out a message with topic discussion points to better assist the people answering the phones so that they could provide more meaningful responses to people when they're calling about specific topics. So you can act on that with Activator. Or, for example, if you were getting a transmission from several vehicles, basically having them going down the roads at higher than posted speeds, you could turn around and send them messages to their console and saying, "We've detected that you are going greater than the posted speed limit. Please slow down." So that's the kind of thing you can do in real time as you're receiving the data. So that data is processed from the event stream and put to a lakehouse. You also we'll look at some of the different ways that you can analyze and transform it. But one of the ways that you can analyze and transform it is by aggregating the data or looking at it in various windowing functions. For example, another company that I worked with they streamed data from freezers because they had the contract for freezers for a number of places that had them. Well, as you know, if you've got ice cream going on there, you don't want to make sure that your freezer temperature exceeds, say, we'll go with 45 degrees over a certain period because otherwise everything will melt and go bad. And that would result in a big loss for the grocery store. But you also have people who stand there with the door open going, what kind of ice cream do I want today? And so the interior temperature may spike for a while. So you want to make sure that when you are analyzing it, you're not analyzing it that, hey, all of a sudden we've got three messages within the last minute that says the temperature is currently above 50 because somebody may just have the door open. So we want to be intelligent about that and maybe look at the average over, say, 10 minutes. And if that average, exceeds our threshold, then we want to immediately send out a technician to ensure that all the food will not be have to thrown out because it is rotten. So these are the kinds of things that we can do with analyzing and transforming it. And then our action would be create a ticket to dispatch a technician. So we have a lot of different ways that we can look at the data that is coming in. There are some great real-time dashboards that are available so that you can take a look at the kinds of transactions you're receiving at any given time. You can choose to query it in real time to see what kind of data you're getting as well, and all of that is in the real-time hub. And again, the data is stored inside of your event house. Of course, you can move that to a lake house, but event house is the place where it is designed to store streaming information. So let's take a look at things about the real-time hub. So the real-time hub is really the centralized location for managing real-time data. So it's a unified place for all the data that shows up in motion. And it lists all the different kinds of streams because you could have streams coming from a number of places, maybe a number of different vehicles or a number of different locations. It lists all the streams and tables that you can query in real time using the Cusco query language, which, since that is a difficult thing to say, is commonly known as KQuil. So you can use KQuil to take a look at querying the data immediately so you can act on it. So it gives you a really easy way to ingest and monitor streaming data from Microsoft Fabric, different kinds of events. So we're going to be taking a look at that real-time event hub and seeing what we get for that as well. So we'll be looking at the different streams and looking at how we can process those streams using different kinds of events. So how do we process our streams? Well, in an event stream. So this is where you see the data coming in. And it is a drag and drop experience, a clicky, draggy, droppy, as Microsoft is fond of saying, so that you can add streams and then add processes to the streams. So you might have a number of streams that you aggregate together. You might also add them to other data so that you can process rules against them so that you have rules that you are using with your streaming data. You can think of it kind of like as a conveyor belt. And then you can process the data coming in with the streams by doing different kinds of analysis or field management on it to determine how the data is performing based on some rules that you have set up. And you can use a table to do that, or you can just create your own rules so that you can create an event, and those are commonly known as reflexes. So reflexively processing information from there and then performing some kind of an action, and then of course storing it. Here we can see that the data is also being stored um, inside of a lakehouse. So you can end up streaming it to and storing the data to wherever you need it to help your analysis processes. So, what kind of process analysis might you do? Well, different kinds of aggregation. You can transform data by maybe filtering. You're going because depending on your stream, you may get garbage, or it may include things you just don't care about. You can remove or perhaps fix the data types for the data you're coming in. I know that a lot of IoT services just send everything as a giant text string, but you might want to transform it to a numerical or a date value that you can get meaning for. You may want to do some kind of a summarization and average over time as that provides meaning. And you might do this over a windowing function. Now, using the example that I talked about earlier, where you are looking at the interior temperature of a freezer inside of a store, you might want to window or aggregate your data over a 5 or perhaps 10-minute interval and then get the average temperature over that period of time. That is called a windowing function. That is how excuse me, hold the data in a way that you can do that, and make a window that has the information aggregated in a way that you want it to. So this operation, you basically, allows you to filter and slice the data that you want. Now, while I am also aggregating the data for, say, in a 5-minute interval, I may want to just also write the streaming data straight to my event house so that I can, keep a record of what kind of data that I'm getting um, in a general stream. And the kind of data that I'm getting in the stream will then allow me to do some kind of further analysis to determine what the regular operations are. Maybe I can fine tune my rules. I can identify perhaps potential problems that I might find over time looking at a larger amount of data. So I might want to also do window it so that I'm aggregating every 5-10 minutes. And I just may want the data every twice a minute, every 30 seconds, because that's the way that the data is streamed. So I might want them both ways. So I can process my stream differently. I can also take that data that is being streamed, just perhaps send it to Power BI. So you've got that real time look of the data. So you can take a look at how you want to do it and process it in many different ways. Now, the event house is the storage location for all of the data that's coming in. So, all the data that you are getting from your IoT device or process is going to be added to the event house. It's designed for handling large amounts of streams, and it uses a language, not T-SQL, but a language called KQL. And it is designed to help you optimize the cost by allowing you to turn this off when it's not in use. So that will help control your your capacity in Fabric, always a concern. And it is really easy to monitor with all of the different tools that are inside of Event Hub, and you can see real-time dashboards that show information about your event house. Now, activator is this is where you are going to provide rules on your data. So if you want to dispatch a technician or you want to send out a message or send an email, this is how you make that happen. It's really a digital nervous system, and it's automatically going to act as an agent based on the rules that you create and make something happen. It's not going to wait around. It's going to see that if a rules condition has occurred, and if that rules condition has occurred, it's going to create that action that you specify. And the action could be anything, could be sending emails, could be sending a Teams message, could be sending a SMS message to your phone or to a bunch of people, sending out repair tickets. All of these things can be created in Activator. And of course, this might be a place where you use your Power Automate skills to create a custom process that it would be kicked off based on a condition set inside of your data. So you create the objects and the rules. And again, these may be dictated by, time slices of analysis on the stream data. And then this information is going to be used to, create some kind of event. So it is a data agent, not going to be waiting around. And this particular feature slash functionality is, I think, is one of the reasons that you see such high adoption of streaming solutions for Fabric, because this is so easy to do, is to not just monitor the data, not just accept the data, but make something happen based on the data using rules that you set up. So it is makes this an active system versus a passive. Yeah, we're doing the stream thing going on, and this, I think, is one of the reasons that you're seeing such a large adoption, is the functionality to do all of these different events based on rules. All right, so let's take a look at how we can set up real-time analytics inside of Fabric. So what I've got here is setting up a new Fabric environment for streaming. So I'm going to first add an event house, and my event house is going to be the storage location where all of my streaming data is going to go. So you can see here that I have my dashboard. Don't have anything in it yet because I've just created my event house, but this is where it's going to go. So of course, when I have my event house, what I'm going to do is I'm going to use it to get data. And this is where I'm going to access my event stream. And so I'm going to access a data stream for bikes, and I'm going to take a look at where these bikes are going, and take a look at that inside of my stream. So I'm going to connect to a sample data stream here to get information on bikes. And when I add that, I get my data source and then my stream. Now it is just streaming until I give it a destination. And the destination that I want to give it is the event house that I created first. This is where my data is going to end up. So I'm going to, add that destination. So this is going to be where my streaming data is going to go. So this is going to be a KQL database, and I wanted to create a new table that is going to contain this information. And it's going to create the data for me, and it is in JSON. And I want to go ahead and activate this after adding the data source. And when I activate it, that means that stream is just starting. So of course I need to publish it to make sure that commit happens. And now it's going to start loading data. So you can see that my stream is active. By the way, you can turn the stream off if you want, when it is not active in use, saving yourself some resource. Now I've got data coming in, and you can see this is all the data that I have. It's telling me the neighborhood, the lat and long, all of that information about my live streaming of data. I'm going to go ahead and refresh it so that I can see that latest data, and it's being loaded to my event house. So my stream is active and my destination is active. I have both of those things active, and the data is being sent there. So this is going to run. And of course, now I'm going to have a whole lot more data that's going to be available um, inside of my dashboard that I looked at earlier. So we could take a look at some of the data insights, and we can see that I've got a number of different processes here that are being sent over. The longer it runs, as I can see different information, different time frames for my data. I can see the incoming and outgoing messages, and I can see how much data that it gets over time. Looking at it over, different time slices as the data is continuing to run. So looking at my dashboard now, I can see that I've got a lot more data that has been added. I can see when it's last run. I can see the tables that I'm being added to. I can see that I'm just adding it to one. I can see the row count, the compressed size, the type of ingestions. In terms of data preview, I can see the data that I'm getting, and I can take a look at the queries that I'm getting for it as well. I've got all of this information that's coming at me about my data. So I can see it coming in and taking a look at what I've got going on. We can see the table details on the right pane there. And I'm going to go ahead and query this with code, take a look at it. Now, again, this is creating a K-quill query for me to do that. Now let's take a look at my stream, seeing my data there. And I'm going to add a new stream. I'm going to add a group by. So I'm going to add the data coming in Event House, but I also want to add a group by condition that I'm going to look at. So periodically, I want to sum my data and take a look at information for the number of bikes that I'm getting. And I want the number of bikes by a condition, and the condition that I want to do that by, number of bikes by, and I'm going to create a tumbling time window. So this is going to aggregate over 5 seconds, and I want it based on street. So every 5 seconds, I'm going to add my data that's coming in so that it's going to do it by street. Now it still has an error because I still don't have a destination. So I'm going to add the same event house for my group by destination. And that event house is going to be putting data inside of a different table. And it's going to show error until I get this destination information completed. So I'm going to, make that information go to my event house. That's where you're going to want to put it. I could also add it to a lake house. I'm going to put it here. So I want to add it to my same, I'm going to call this Bikes by Street table, same workspace, same event house that I had before, but same database, but I want to do a different table. So I've got my bikes table already. I'm going to create a new table, and that table is going to be Bikes by Street. My bikes by street table is going to contain that data that is summed up every 5 seconds based on that. So now I've got my data displayed in 2 different ways, and I'm going to go ahead and publish it. And when I publish it, now I'm going to have my data written twice. So I'm going to write it to 2 different tables. It's the same data, but I'm going to have a difference between the information which is aggregated versus the information that has been streamed. So I've got different data loading here, and I can, of course, query both of that as well. So it's busy loading it up to my Bikes by Street table. And we can preview the data coming in here, and we see now we have streets, number of bikes, and then of course the end time, the time that it is being written. So I'm going to see, every 10 seconds, I'm going to have that information available there. Now, if we look at data preview, we'll see that. But if we look at data insights, we have more things that we can take a look at. So you can see that I've got the information that's coming in now for both streams. So I've got a lot of information that I can take a look at. Going back here at data insights, also we can see that we can change some of the options that we're looking at. And we also have multiple views of the data. I could also look at any kind of a delay that I'm getting in receiving my data, seeing anything that's backlogged or just my output or the delay that I have created for it. So if we go back to my event house from my stream here, I can take a look. I'm going to refresh it because I did add that new table. We're not seeing it yet. So I'm just going to do a quick refresh on my event house there. Refresh the data in tables. And we can see that I've got both bikes and bike by street. And here I'm going to refresh it so that I can see that table showing up here in my tables section. So I'm just going to do a quick query with that to say query with code. And I'm just going to say, give me the data. And notice that in K-quill, that is take 10. So any shortcuts I have would be below it as well. So now I am seeing my data preview. I can look at the hours or by day, looking at the data that I have and taking a look at that over time. So we can take a look at my schema and we can see the top 10. Top 10 are all 3 of them with the exact same ones, different streets that the bikes are being found on. So we've got a lot of different things that we can take a look at in here. And now take a look at our dashboard. We can see the activity, the ingestion. I'm the only on top user. We can see if there were some errors. And yes, there were some errors. So we might want to take a look at that data. And we can take a look at it, of course, in different time frames, taking a look at how that looks. And of course, that green indicator will let us know that it is indeed running at the moment, and how much data that is being brought in. I find it interesting, compressed is greater than the original. So refresh it and we can see the latest data. And yeah, I'm the only one who's played with it. And it's only going to the event house. No other location is set up for it. So this is how we can take a look at our data, how we can set up a stream, saw how easy that was to understand how to set that up and then start processing it inside of Fabric. All right. So KQL is a language that we are going to be using to analyze this data, and it is a little bit different. For those people who are familiar with SQL Server, you'll find that working with KQL can be quite challenging because it is not the same. I'll also say that, like many new languages, it's not so, Copilot doesn't know it very well, so don't want to count on the results that you get back. They may or may not help you out with that. The queries are a little bit different. They're composed of a bunch of pipe operators, and it is case insensitive for the column names and street values, not for the keywords. So here we see what the format is, and that is table name, where condition, your summarize, and then your order by. So let's take a look at this inside of Fabric. So going ahead and taking a look at my event house here. This is the same one that we looked at earlier. So just going back um, from the query to taking a look at the system overview and taking a look at our dashboard that we see here. We've got the event house, we've got the activity. We can take a look at the activity over the last 30 days, see if there's been some kind of variation. Um, Seeing different ways that we have our data, top query databases, activity minutes, and then what's new, and information here about the details. Of course, we can close that pane to make it larger. So this is the database, this is the system overview, and we can see that it is currently running. We can take a look at the minimum consumption, and this is just going to show us how we can determine how we want to be charged. So I'm doing on demand, which is changes, and you can set this to a fixed method if you wish to do that as well. And this is showing us whether or not the interface is going to do live. I do want it to be live. That's why it's showing this way. And if we look at monitoring, we can see that this is going to make our data in logs show up in our monitoring section. All right, so let's take a look at our event house here and take a look at how we can use this to do different kinds of queries. So to query, all we want to do is then select query with code. We have this database selected, so we're just going to go to our query as code section. Now, one of the things that queries that I have created, let's just take a look at some of the queries here. Now, here is a simple one using a take to make the number of records in the table and check the data. So this is the same as a top 100. Um, Oops. And you'll notice here it tells me that I need to do Shift Enter to reactivate this. So Shift Enter is how I'm going to do that. Now that is the easiest query to do because frankly, I don't have to write it. So all you need to do is select the magical ellipse menu, and then you can choose to do different kinds of queries with it. I can say, look at any 100 records ingested in the last 24 hours, show the total count or summarize ingestions per the past hour. And this shows me that how I would do that in SQL as well. So we can see here that I can also write the same thing inside of a SQL statement inside of my lakehouse. Microsoft knows that a lot of people are not interested in learning any language and they just want to run it inside of a T-SQL command. This provides you the ability to do that as well. I know they're going to be adding more in because, frankly, nobody wants to learn a new language. We're also hidebound in the tools that we already know. So if I'm going to query with code, These are the only SQL ones that are available, but let's take a look at count of records inside of KQL. And that is a simple count command inside of our bikes table. Now let's take a look at doing something a little bit more complicated. This is using the KQL command. So I want to look at it. Notice I've got a double equal sign there. I want to just take a look at where the street equals Pall Mall East. Notice that is double quotes, by the way. And the queries disable themselves. And so when they are disabled, like they are here, you need to type Shift Enter to make that run. So you can see here I have 107, and we can take a look at the stats. And looking at the stats is really kind of interesting because we can see a lot of information about our query. We can see the rows, the size, the disk cache, and then we can see the JSON data because this data came in as JSON, and we are just reading it here. So a lot of information about our statistics here, and we can even add other visuals to it if we wanted to do that. So, and I don't, so I'll just go back. So you can get a way of doing that if you want to take a look at that for different kinds of visual formatting. So now let's take a look at another query. I wanted to take a look at the most recent data, the records generated in the last 24 hours, and taking a look at that based on the ingestion time. So if I run this again, we can take a look at the data that is coming in. We can see that we've got more records than we had previously because again, this data is being streamed live. And if we had any empty columns, we can of course hide them. Really kind of a nice feature that they add there. If I have any kind of request, I can process that to a clipboard, and I can expand my view. If I wanted to do make it right or left, I can play around with it because this is not the same thing as working with a lake house or an event house. While I can make that a destination, if I wanted to edit any of this data, then I'm not going to don't have the ability to do a SQL endpoint. But if I'm like, you know what, I just really want to just look at all of this inside of SQL, I can take a look at my stream. I can add other destinations to that. And right now I've got destinations for my bike stream of my event house, just a straight up stream. I can also, edit this and choose to scroll down, add additional elements. So I can add a source, and I could add a custom endpoint, and that could be something like a lake house, and use that so that I can put that inside of my data as well. So I can add another destination. Let's say that I would just really want to look at this inside of my lake house. And I'm going to add my stream to it, but I need to make sure that I give it a place to do it. I'm going to have this be my lake house stream. And one inside of this workspace. And I'm going to need to create a lake house to do that, not a problem. I'm going to then just go ahead and select a lake house and call this stream data. Create that. Back to my stream here. Edit. Didn't save it, so I'm going to have to do this again. So I'm going to add my destination again. And stream data, workspace, either RTI, lakehouse, stream data. And I want to create a new table. And I'm going to call this bikes. Done. My JSON format. Now, go ahead and save it. So I don't have any errors here. I can go ahead and publish this. And now my data is also going to my lake house, which means if I'm decide that I just don't want to deal with having to learn a lot of cake, well, then this can be my location for my stream data as well. When it's done loading, we'll take a look at that. So it's busy loading it up now. We can take a look at it after it's done loading because it does take a little while to do this. Let's wait and let it load. And notice here that I refresh this. You can see my event house. You can see that I've had some queries fail. I've got my different methods of doing that, my data preview. Let's take to look back at my event house here. And now, of course, it's still loading data. Let's take a look and see if we got any data yet inside of my lake house. You can do that by opening this up here. And not quite yet. But when it is done, I will be able to see this here. We can get our latest and greatest of our data. Taking a while to generate. Still loading. But you'll understand that it will work the same way as my events house does. So I can start using that for querying. So we'll let that finish up here after the demo so we don't have to wait around to watch data load. All right. So this is a great tool. So why might you, or what kind of companies might be interested in doing this kind of work? Well, I worked for a water utility inside for the state of California, and they have some very specific rules when it comes to wasting water. Wasting water is not something that they want anyone to do, so that they've got sensors set up in the water mains, which go down generally the center of the street, so that they can instantly dispatch a technician if there has been any kind of a break detected in a water main so that they don't waste a lot of water. And they also have one at the subscriber level so that subscribers can know, hey, all of a sudden the usage popped up. What do we want to do here? There's different rules involved because maybe some subscriber usage popped up because they're trying to fill their swimming pool. You just never know. So in that case, they call before they dispatch a technician. So what they wanted to do is they wanted a solution that allowed them to solve these two problems, what their IoT data that they were getting from the pumps inside the water main and then at the individual subscribers. And the solution for this is basically taking a look at real-time intelligence in Fabric, hooking up their IoT data to Fabric so that they could get that data and process it in real time so that water's not leaking all over the place. So this is allowing them to monitor the data and then implement different steps in Activator to dispatch a technician in the case of a water main. So they had two different kinds of IoT devices that they were working with, and they had different identifiers. So they were processed in different streams. And then they had one for the individual subscriber IoT devices at those pumps so that they could contact them if they determine abnormal water usage. So the other thing that they did is they looked at their existing data store for what is normal and abnormal water usage for a given customer so that they knew if somebody was within range and they just would want to randomly call. And those varied quite a bit with different people, different household sizes, etc. So these rules were set up based on the location information. So for this, we're obviously going to need to use an event house to store the data, processing the different streams, and then Activator to make these different things happen. So this would be a great scenario to implement real-time data ingestion using Fabric. All right, so we talked about, the processing of real-time data, and that's also a really challenging thing that companies are needing to do. And there's lots of different ways that you can handle it, but the tools inside of Fabric really provide a great ecosystem for not only managing the streaming, but managing the events that you want to occur as a result of the data that you're receiving. All right, what do you think, Toral? Is this something that you think that a lot of customers will probably be interested in soon?
Absolutely, Ginger. I mean, and this was great, very insightful presentations, and just sharing, your multiple use cases. I think it's going to really resonate well with organizations who are looking to embark on this journey with, real-time analytics. Ginger, we do have a few questions. So the first question is, what does K stand for in KQL?
K stands for Kusto. It is the Kustos query language. So Kusto. And
Okay.
it is something that Microsoft created. And it works also for the anything in log analytics. The language is originally designed for that.
Okay, perfect. The second question, Ginger, is can I create a Power BI report directly from Event House, like a direct lake report?
Technically, you do it direct from the stream because it's not even being written to the event house. It goes straight to Power BI. And the answer to that is, of course, yes. I'm sorry I didn't demo that.
Okay, perfect. Yeah, we have a question, Cousteau, question mark, from Vetri. I think, Ginger, can you just talk a little bit more about, Cousteau?
So, the KQL language, Kusto, is something that Microsoft created to handle log and data that does not change. That's the thing about IoT data. You don't edit it, it just is. And originally, log analytics data was designed for this, and they wanted something that was specific to this kind of data. It's generally not stored in the same kind of structure as a SQL is. It's primarily designed as JSON. And so it handles obviously Parquet because that is what it's stored in, but it's designed for larger data sets that do not change. There isn't a way to say insert a record inside of Cusco or create or modify a record because the language really doesn't design to support that.
Great. Thank you, Ginger. And Vetri, if you have, any additional questions, please feel free to reach out to us. Happy to answer, any further questions on KQL and Kusto. So I think at time, Ginger. As we wrap up this session, I want to thank you for the insightful presentation and walking us through how Fabric can unlock real-time insights using event stream, T-SQL, KQL, as well as Event House. And if you're exploring use cases like IoT, streaming, customer behavior tracking, or even real-time analytics dashboards, this is a real game changer, going with real-time analytics. So if you would like to dive deeper or explore, putting together a POC, please feel free to reach out to us. We would love to help you get started on your journey with real-time analytics. You can contact me directly at tigoradia@santortech.com, or feel free to visit our website, www.santortech.com. Thanks again all for your participation and have a great day. Thank you
Thank you.
all.
Bye bye.